Hello and welcome back to PharmaHealth Insights. Let's explore the top 20 UV spectrophotometer troubleshooting challenges and solutions. Let me take you into a real QC moment. You are standing in front of the UV spectrophotometer. Everything is routine. Everything is under control. You prepared your sample carefully, exactly as per the method. You place the cuvette, run the analysis, and then something feels off. The absorbance is not what you expected. You pause, maybe a small mistake. You prepare again. You run again. Still wrong. Now your mind starts racing. Production is waiting. QA is expecting results. And slowly that pressure starts building. And in that moment, one question repeats again and again. What went wrong? Now I want you to be very honest with yourself. In that exact situation, do you think or do you just repeat again? Because that single decision defines whether you are just running an instrument or truly understanding it. Let me say something very clearly. In most laboratories, when results go wrong, the problem is not the instrument. The problem is how we react. We don't pause, we don't analyze, we don't think, we just repeat again and again, hoping the results will correct itself. But let me ask you, has repeating ever truly solved the root cause or has it only delayed it? Today, I want you to shift from reaction to structured thinking because troubleshooting is not trial and error, it is logic. Now I'm going to give you something extremely powerful, a simple framework. Whenever UV gives you a problem, do not jump randomly. Follow this exact sequence. First, instrument. Second, cuvette. Third, blank. Fourth, sample. And fifth, the method. Now pause and think honestly. How many times have you blamed the sample first? Almost every time. But in reality, sample is not the first suspect, it is the fourth. If you follow the sequence with discipline, you will eliminate confusion and troubleshoot with clarity. Now imagine this, you enter the lab, you switch on the UV, nothing happens. No display, no response, complete silence. Now immediately the mind jumps to a conclusion. Oh, the instrument has failed. Engineering is called. Work is delayed. Time is lost. But let me ask you something very basic. Did you check the power cable? Did you check the socket? Did you check the fuse? I have personally seen situations where operations stopped for hours and the issue was simply a loose connection. Now understand this clearly. This is not an instrument failure, it is a thinking failure. So what should you do? Always start with the simplest possibilities. Check power, check connections, eliminate basics, then escalate. Because good troubleshooting always moves from simple to complex. Now let's move to a more subtle and dangerous situation. The instrument is working, everything appears normal. You run your standard and the absorbance is lower than expected. You run again. Now it fluctuates slightly. Now let me ask you, what is your first instinct? Most analysts immediately suspect the sample. But let's step back. Let's think like someone who understands the system. What are the possibilities? Sample, method, or instrument? Now ask yourself logically, is it more likely that your sample suddenly became incorrect or that your light source is weakening? Because UV depends entirely on lamp intensity and lamps do not fail suddenly. They degrade gradually, which means your results become unreliable before the instrument shows any obvious failure. So what should you do? Check the lamp usage hours. Compare with the recommended life. If it is nearing the limit, replace it proactively because waiting for failure is not control, it is reaction. You run a blank and the baseline is drifting slowly, not sharply, just gradually moving. Now I want you to stop here and think, what is the instrument trying to tell you? Because this is not just a visual fluctuation, it is a signal. The instrument is trying to tell you, I am not stable yet. Now, what usually happens? We ignore it and proceed with analysis. And later we repeat everything again. So what should you do instead? Allow proper warm up. Let the system reach equilibrium. Observe until the baseline stabilizes. Because if your starting point is unstable, your result will never be reliable. You prepare your calibration standards carefully. Everything is precise, everything is controlled, but when you plot the curve, it is not linear. At higher concentrations, absorbance starts decreasing. Now confusion begins. Is it a dilution mistake? Is it a pipetting error? But let's step back and analyze. This pattern indicates stray light, unwanted light entering the detector, reducing the apparent absorbance. Now understand the seriousness. The data does not obviously looks wrong, but it is misleading. So what should you do? Perform stray light testing, verify instrument performance, and if required, call for servicing, because the most dangerous errors are the ones that look acceptable. Now let's focus on something very small but extremely powerful, the cuvette. You pick it up, it looks clean, transparent, fine. You proceed with analysis and results are inconsistent. Now tell me honestly, how often do we question the cuvette? Very rarely, but even a fingerprint, even a minor scratch, even a thin residue layer can disturb the light path. So what should you do? Handle cuvettes carefully, hold them from the sides, clean them with lint-free tissue, inspect them against light and replace if damaged. Because in UV analysis, the cuvette is not just a container, it is a part of the measurement system. Now let's move to a situation that looks very small but creates very confusing behavior. You run your sample and the reading is not stable. It is fluctuating, small spikes, sometimes normal, sometimes not. Now stop here. What would you think first? Instrument nice, electrical issue, but let's slow down. Instead of guessing, observe. Take the cuvette out, hold it against light. Look closely. Do you see tiny air bubbles? Almost invisible but present. Now understand what is happening. Light is supposed to pass through uniform solution, but instead it is getting scattered by these bubbles, and that scattering creates instability in your absorbance. Now let me ask you honestly, before placing the cuvette, do you really observe it or do you just fill and insert? This is where professionalism begins. So what should you do? Fill the cuvette slowly. Avoid turbulence. If bubbles are formed, tap gently to release them. Degas the sample if required. Always inspect visually before placing, because in UV analysis, what you see is as important as what you measure. Now let's move to something even more critical, your blank. You run the sample and suddenly you get strange values, sometimes even negative absorbance. Now let me ask you, can a sample really give negative absorbance? No. So what does that tell you? Your reference is wrong. Because UV does not measure absolute values. It measures relative to the blank. Now think about the common mistakes. Using water instead of buffer, using an old blank prepared long back, using a contaminated solvent, and then expecting correct results. Now let's think logically. If your starting point itself is wrong, how can your final result be right? So what you should do? Always prepare a fresh blank. Ensure it matches your sample solvent exactly. Never reuse blank casually. Run blank and verify baseline before sample, because blank is not just a step, it defines your entire measurement reality. Now imagine the situation. You prepare your sample. It looks slightly hazy, not perfectly clear. You hesitate for a second. Then you think it should be fine. You run the analysis. Absorbance is higher than expected. Now immediately, SA is high. But pause. Let's step back and think scientifically. What does UV actually measure? Light absorption. But what does turbidity do? It scatters the light. And UV cannot differentiate between absorption and scattering. So what is really happening? Your sample is not absorbing more, it is scattering more light, and you are misinterpreting it as higher concentration. Now ask yourself, are you measuring chemistry or physical interference? So what should you do? Check sample clarity before analysis. If turbid, filter or centrifuge. Ensure solution is optically clear. Rerun only after the clarity is achieved, because clarity is not an option in UV, it is a fundamental. Now let's talk about something very common. You prepare a strong sample, you think stronger signal, better accuracy. You run the UV, absorbance is very high, but readings are inconsistent. Now the confusion starts again. Instrument problem? But pause. Let's think scientifically. Beer-Lambert law. It works only within a defined range. Beyond that, the linearity breaks. So now, even if your preparation is perfect, your result becomes unreliable. Now ask yourself, did you check the absorbance range or did you just report the value? So what should you do? Dilute the sample appropriately. Bring absorbance into working range. Confirm linearity before reporting, because in UV, correct range matters more than the strong signal. Now imagine everything is perfect, instrument, sample, preparation, but the result is still wrong. Now think, are you asking the right question to the instrument? Because wavelength defines what you are measuring. If you select the wrong wavelength, you are measuring something else entirely. It's like tuning to the wrong frequency and expecting the correct song. Now let me ask you, do you verify wavelength every time? Or do you trust the saved method blindly? So what should you do? Confirm the lambda max from method. If doubt exists, perform a scan. Verify before proceeding, because one wrong wavelength can make everything else meaningless. Now let's go one layer deeper. Same drug, same method, but the results are different. Now frustration increases. Everything is same, then why difference? Let's think chemically. Many compounds are pH sensitive. A slight change in pH changes ionization, changes absorbance. So what is happening here? Your chemistry has changed, not your instrument. Now ask yourself, did you verify the pH or just assumed it? So what should you do? Prepare buffer carefully. Calibrate the pH meter. Verify pH before use, because in UV analysis, chemistry is driving the signal. Now let's revisit the calibration. Curve is not linear. Immediately we say instrument issue. But pause. Let me ask you honestly, was your preparation perfect? Pipetting errors, small dilution mistakes, they accumulate and suddenly your curve becomes distorted. Now the instrument is correct, but your preparation is not. So what should you do? Always use calibrated pipettes. Follow dilution steps very carefully. Prepare standards with focus. If doubt exists, prepare fresh, because sometimes the problem is not in the machine, it is in the method execution. Now friends, let me ask you something very honestly. Have you ever switched on the UV and immediately started analysis? Yes, we all have, because of pressure, deadlines, workload. But what happens next? Unstable readings, repeat analysis, more delay. So what did you really save? Nothing. Now think logically. Instrument needs stabilization. Without that, results cannot be consistent. So what should you do? Always allow proper warm-up. Run blank till stable. Then proceed, because rushing at the start costs more at the end. Now let me give you a situation that creates silent confusion. You run the sample, result is not matching expected value. You repeat, still different. Now your mind starts going in all the directions. Is it sample issue? Is it instrument problem? But stop. Let's slow down and think carefully. What exactly changed? Same method, same sample, same instrument, then why is the result different? Now look at one small detail. Did you change the cuvette? And if yes, did you check the path length? Because in UV, absorbance is directly proportional to the path length, which means even if everything else is perfect, a change in path length will change your result. Now, this is where many analysts make a mistake. They assume all cuvettes are the same, but even slight variation or using a different type can shift your values. Now, ask honestly before using a cuvette, do you verify it or assume it? So, what should you do? Always use standard 10 path length cuvettes unless your method specifies something else. Ensure consistency across all measurements. Do not mix cuvettes randomly during analysis. If you replace cuvette, recheck your baseline and readings because UV is not just experimental, it is mathematical, and mathematics does not forgive assumptions. Now let's look at a situation where everything looks perfect. Instrument is working, sample is prepared correctly, the cuvette is clean, and still the result is wrong. Now this is where the frustration increases. Everything is correct, then why is it wrong? So let me ask you, what exactly are you telling the instrument to do? Because UV does not think. It follow instructions. Now imagine a wrong method is selected, a wrong wavelength is entered, a wrong factor is applied. Now the instrument is doing exactly what you told it, but what you told it is wrong. This is a very important realization. Now ask yourself, do you verify method parameters before every run or do you trust the safe methods blindly? So what you should do? Always cross-check the method before analysis. Verify wavelength, mode, calculation factors. Confirm the correct method file is loaded. Do not rely on memory. Verify every time because in automated systems, errors don't shout. They quietly give you the wrong signals. Now let's step outside the instrument for a moment. Look around your lab. Everything seems normal, but your readings are fluctuating slightly. Not drastically, but enough to create doubt. Now, what do most people do? Blame instrument, blame method, but rarely they look at the environment. Now think about it. Strong airflow from the air conditioner, vibrations from nearby equipment, dust accumulation, all these can affect optical stability. Now it may not cause a complete failure, but it creates subtle variations, and those subtle variations create confusion. Now ask yourself, is your instrument placed in a stable, controlled area? So what should you do? Ensure minimum airflow disturbance near the instrument. Avoid placing UV near vibrating equipment. Maintain cleanliness around optics area. Keep instrument environment controlled because not all problems are inside the instrument. Some are silently coming from outside too. Now this is one of the most critical moments. You perform calibration and it fails. Now let me ask you very directly, what do you do next? Do you try quickly again and proceed or do you stop and investigate? Because this is not a small warning, this is a fundamental failure. If wavelength accuracy fails, you are measuring the wrong region. If photometric accuracy fails, your absorbance values are wrong. Now think about it. Can any results be trusted after that? No. So what should you do? Immediately stop the analysis. Reperform calibration carefully. Check standards and procedure. If still failing, call for service because proceeding after failed calibration is not just an error, it is a risk to data integrity. Now, after all the scenarios, let me ask you something honestly. How many of these problems were actually complex? Very few. Most of them were simple but missed. Why? Because of how we approach the situation. We assume, we rush, we repeat without stepping back and thinking. Now, this is the real root cause, not technical, it is behavioral. So, what should you do? Build a habit of pausing before repeating. Follow a structured troubleshooting sequence. Observe before acting. Think before concluding. Because the difference between an average analyst And an expert is not knowledge alone, it is how they think. Let me leave you with a real situation. An OOS result was reported. Immediate pressure, batch on hold, investigation initiated. Every possible factor was checked. Method, instrument, sample, everything looked fine. Finally, the root cause was identified, a fingerprint on the cuvette. Just a fingerprint. Now pause here. Think about this deeply. Such a small oversight and such a large consequence. Now ask yourself, how many times have we done this without realizing? This is why attention to detail is not optional in QC, it is critical. So after everything we have discussed, let me leave you with one final thought. UV spectrophotometer is not a complex instrument, but it demands a disciplined mind. Anyone can press run, but not everyone can interpret, observe, and diagnose. So next time you face an issue, don't panic. Don't repeat blindly. Pause, observe, think, diagnose, because that is what transforms you from someone who operates an instrument to someone who really understands it. So friends, if this session made you pause and think, then it has done its job. Now I want you to do one thing. Think about the last UV problem you faced and write it in the comments. I personally go through them and help you solve them step by step. If you found this useful, like the video, share it with your QC team, because this is something every analyst should know. And subscribe to PharmaHealth Insights, because here we don't just run instruments, we understand them in a way that builds confidence.